Alright, so we're going to look at an example of the extreme value theorem. Let's go ahead and review that theorem really quick. Alright, so the extreme value theorem says if f is continuous on a closed interval ab, then f attains both an absolute maximum value f of c and an absolute minimum value f of d at some numbers c and d and ab. So we want to find the absolute max and absolute min of this function on the closed interval pi over 4 to 7 pi over 4. Now recall in class that I said it's always a good idea just to make sure that the given function is in fact continuous on this closed interval. So we can see here that this function is a sum of two functions, linear function, which is continuous for all real numbers, and cotangent of t over 2. Now cotangent will be continuous as long as t is in the domain of this function. So in this case, that's if t over 2 is not equal to, and cotangent is undefined whenever the argument of the function is any multiple of pi k. So in this case, if t is equal to 2 pi k. Right, so t cannot be any multiple of 2 pi k. So the good news is that none of these values, no multiples of 2 pi, are in this interval. So what that means then is that this function f is continuous on this closed interval. Alright. The next thing we want to do is we want to go ahead and find the derivative. So f prime of t is going to be equal to 1 plus, using the chain rule here, we're going to get the derivative of cotangent. Actually, that's going to be minus cosecant squared, keep the argument the same, over 2, and then take the derivative of the argument, 1/2. So we'll go ahead and just put the 1/2 right there, and that will be our derivative. Alright, so the next thing is we want to know when the derivative is 0 or undefined. We want the critical numbers of the function. So we found the derivative, now we want to find the critical numbers. We find the critical numbers by looking at when the derivative is 0 and when the derivative is undefined. So f prime of t is going to be equal to 0 when 1 minus 1/2 cosecant squared of t over 2 equals 0. We can subtract the 1 and then multiply by 2. We get cosecant squared of t over 2 equal to 2. Taking the square root of both sides, we get cosecant of t over 2 equal to root 2. If we want to be if we feel more comfortable working with signs, we can take the reciprocal of both sides. Oops, forgot the plus or minus, apologize. Take the reciprocal of both sides, so we get sine of t over 2 equal to plus or minus 1 over root 2. Okay, so the next thing we want to know is when is the sine, for what values of t will the sine of t over 2 equal this ratio? So actually I'll write it like this first. So we have sine of t over 2 equal to 1 over root 2, or sine of t over 2 equal to negative 1 over root 2. If the ratio is positive, we know that sine can take on positive values in quadrant 1 and quadrant 2. The sine of an angle that corresponds to pi over 4 is going to give you 1 over root 2, or the sine of an angle whose reference is pi over 4 will give you 1 over root 2. So in quadrant 1, that means then that t over 2 is going to be pi over 4 plus 2 pi k, or t over 2 will equal to 3 pi over 4 plus 2 pi k. Alright, and then solving for t, this implies that t will be equal to pi over 2 plus 4 pi k, or t will be equal to 3 pi over 2 plus 4 pi k. Because we want the values to be between 0 and, pi over 4 and 7 pi over 4, k can only be 0, so that will give us just the two values of pi over 2 and 3 pi over 2. Alright, so that's that part. Then we need to look at when is it negative. Well, if it's negative, then in this case we'll have that t over 2 will be equal to, if it's negative, that means we're going to be in quadrant 3 or 4. In quadrant 3, it's going to be 5 pi over 4 plus 2 pi k, or t over 2 will equal 7 pi over 4 plus 2 pi k. Okay, and then likewise solving, that means that solving for t, that means that t would either be 5 pi over 2 plus 4 pi k, or t would equal 7 pi over 4, or 7 pi over 2, apologize, 7 pi over 2 plus. Alright, now notice, so in this case, notice that no matter what we do, even if k is equal to 0, 5 pi over 2 and 7 pi over 2 are not going to be in the closed interval that was given to us of pi over 4 to 7 pi over 4. And especially if k is 1, then we're way outside. If k is equal to negative 1, then we're still not in that interval. These will be negative angles at that point, so that wouldn't work for us. So this side is not going to give us any critical numbers in the interval pi over 4 to 7 pi over 4. So right now, it only seems as though these two are the ones we're going to use. Okay, now what we actually have to still check, going back here, I'll come back down to that in a second, but coming back up here, I want to know when is f prime undefined. Okay, so f prime will be undefined looking at this expression whenever a cosecant of t over 2 is undefined. So when is cosecant of t over 2 going to be undefined? Well, because cosecant is 1 over sine, cosecant of t over 2 will be undefined whenever t over 2 is equal to pi k. This should look familiar because this is the same restrictions we had on the original function. The original function, and if you see here, that makes sense because cotangent, so we're looking at the original function, cotangent is cosine over sine, sine in the denominator, when is sine 0, multiples of pi k, and then the function that we're, the derivative has a 1 over sine in it, when is sine undefined, or when is sine 0, any multiple of pi k. So, but the point is that none of these values are going to be in the interval that we are looking at, so therefore we don't have to worry about these values, so we can just ignore those. So the only critical numbers are going to be pi over 2, t equals pi over 2, and 3 pi over 2. Alright, now that we've done that, now what we need to do is evaluate the function at the endpoints of the interval and the critical numbers. So let's start with f of pi over 4, and we substitute these back into the original. So f of pi over 4 is going to be pi over 4 plus the cotangent of pi over 4 over 2. And give me a second as I approximate that really quick. Alright, so after punching this into the calculator, we get that f of pi over 4 will be approximately 3.1996. F of pi over 2, which is going to be pi over 2 plus the cotangent of pi over 2 over 2. And that's going to be approximately 2.5709. F of 3 pi over 2, that's going to be equal to 3 pi over 2 plus the cotan of 3 pi over 2 over 2. And that's going to be approximately 3.71238. And then the last value that we're going to check is f of 7 pi over 4. So that's going to be 7 pi over 4 plus the cotangent of 7 pi over 4 over 2. and that's going to be approximately 3.0835. Alright, now to get the absolute min and absolute max, we simply pick the smallest value for the absolute min and the biggest value for the absolute max. So our conclusion is that the absolute max is f of 3 pi over 2, and the absolute min is f of pi over 2. Okay, and that's how you find the absolute max and min of a continuous function on a closed interval using the extreme value theorem.